Hi guys, in this video we are going to work with question 4. We are still on June 2023 mathematics Gauteng, yes, provincial paper. So yes, let's work on question 4. As we can see from here, guys, we are given a parabola, given f of x, and we're also given a straight line. So what we are looking for, the first part is that we need to show that the turning point of f is 1 and negative 4. So we're actually looking for the turning point of a graph of f of x, right? Let's put that into practice without wasting time. Since we are dealing with the turning point, we are going to use this formula to calculate the turning point. We can say x is equals to negative b all over 2a. This is the formula you're going to use if you're calculating for the turning point of a parabola. So remember that we were given as x squared minus 2x minus 3. So this was the equation of f of x. Okay. So meaning that where we see B, remember that this is A and this is B and this is C. Where we see B, we are going to put negative 2, right? And where we see A, we are going to put 1, the coefficient of x squared, right? So from here, negative and negative, that's going to be 2. 2 times 1, that's going to be 2. Then 2 divided by 2, that's 1. We already proved that one. Then from here, what you should do is to take this x turning point and substitute to the original equation there. So let's just say f of 1 is equals to 1 squared, where that is x substitute 1. Then we know that 1 squared is 1, 2 times negative 1, that's negative 2, minus 3. Okay, that's 1, negative 2 times 3, that's negative 2. Then 1 minus negative 2 is negative 1. Negative 1 minus 3, that's minus 4. So in other words, now we know that the turning point is negative 1 and negative 4. Right? Okay. That means we have already proven, we've already shown that the turning point of f is 1 and negative 4. So that's 3 marks. So let's go to the second part. 4.1.2, determine the coordinate of x and y-intercept of the graph of f. Still working with the graph of f, but now we need to determine the coordinates. Okay, let's put this into practice. Okay, we are going to work with 4.1.2. Okay, so we are looking for the x-intercepts of this graph. So for the x-intercept, you will let y be 0. Then meaning that where there is f of x, you will replace it by 0. So we are going to have 0 x squared minus 2x minus 3. So from here we need to factorize, since this is a trinomial. So the factors of 3, that will give us 2, it's 3 and 1. So you're going to have 3 and 1. So to get to negative 2x, the bigger sign must have a negative sign in this case. So we have x here as well as x, and we're going to have plus, because negative 3 plus 1, that's negative 2. Negative 3 times 1, that's negative 3. So when you equate, we now equate everything to 0. X minus 3 equated to 0, x plus 1 equated to 0. So taking negative 3 to the other side, we get positive 3. Taking 1 to the other side, we get negative 1. Right, so remember they wanted us to determine the coordinates of x and y. So here the coordinates will be 3 and the y value is 0, as we've stated. Or similarly at this point, we are going to have negative 1 and 0. So they also said that we need to determine the y-intercept of the graph. For y-intercept, guys, let x be 0 in this case. So what are we going to do? We are going, where we see x, we're going to place 0. So it's going to be 0 squared. 0 here, put 0. 0 squared, that's 0. Negative 2 times 0, that's 0. 0 minus 0 is 0. Then 0 minus 3, that's minus 3. Then y is negative 3. So the white coordinate 0 and -3. So we have already got our 3 marks. Already we are on 6 marks now. So we need to get now determine the coordinate of the point of the intersection, the point of intersection of the graph of graphs of f and g. That's 4 marks, right? Let's put that into practice. Okay, so because we are looking for the x-intercept, the point of intersection of both graph, what you should, it happens where f of x actually and g of x meet, where they are equal. So f of x and g of x are equal. Then let's place x squared here, minus 3x minus 3, sorry for that, and x minus 5. So we need to group these like terms so that we write it in a standard form. So we have x squared here minus 2x. Then when you take x to the other side, it becomes negative 3x minus 3. Take 5, it becomes plus 5, equated to 0. So x squared, the like terms, this will be, all right, what did I do here? Oh, I was supposed to take x. I don't know where I came up with this 3x. So it should be x sort of for that. So that will be x. So that will be minus x, and also when we take negative 5, it becomes positive 5. So the like terms here, negative 2x minus x, that's going to be 3x. But negative 3 plus 5 is the same as 5 minus 3, which will be positive 2 in this case. Okay, so we will then factorize. We will then factorize the factors of x squared, it's x. Factors of 2, it's 2 and 1. That will give us 3. So because the last term is a positive sign, they will take a sign of a middle term, so both of them will be minus. So negative 2 minus 1, that's minus 3. Negative 2 times negative 1, that's positive 2. So they are actually correct. When you equate this, you're going to have x is equals to 2 or x is equals to 1. Okay, we are not done. What we should do, guys, now, remember they said we should determine the coordinate of the point of intersection of both graphs. So we already have the x-intercepts, So what we should, this is 1, sorry for that. So we can take this x values and substitute to any of the graph. Let's substitute to the graph of g of x, which is y is equals to x minus 5. So let's take 2. Let's start with 2. 2 minus 5. 2 minus 5, that's minus 3. So we're going to have 2 and negative 3. The other one, let's substitute 1 minus 5. That will be minus 4. So 1 and negative 4. Can you notice that there's something common here? We have a similar coordinate here. 1 and negative 4 reminds us of what we did there at 4.1. Yes, they share the same coordinate. All right, so let's go to now we are going to 4.1.4. Sketch the neat graph of f of x and g of x on the same set of x's. Okay, clearly label the turning point and where the graphs of f and g intersect each other, as well as the x-intercept and the y-intercept of both graphs. So we should include everything that we did there. Right, without wasting time, let's put this into practice. At 4.1.4, we're supposed to sketch, guys. So let's sketch. Right. Okay, you know, y-axis. It's okay, it's fine. We'll start with the x-intercepts, guys. As we can still remember, what did we got? Let's place everything here. Yes, let's start with our turning points. Then we have 0 and negative 1. That was the coordinate of we start with the graph of f, actually, negative 1 and 0. The other one, 0, 1, 2, 3. Then we have 3 and 0 here. Okay, those are our points. So the y-intercept, you also have 0, 1, 2, 3. That was 0 and -3 in this case. Then we also had the negative, the turning point, which was 1, 0, 1, and -4. So that's supposed to be here, 1 and -4. So let's sketch our graph. Okay, yourself have to sketch it. Well, okay, that's the graph of f. So now, okay, you need to sketch the graph of the straight line. Remember that the graph of straight line was y is equals to x minus 5. So if you can place 0 here to get the y-intercept, our y-intercept will be -5. So we are going to have 3, 4, 5. So it will be somewhere here. So we are going to have 0 and -5. So guys, don't remember your point of intersection 1 and -4 was also part of the intersection. We also did have 2 and -3, 0, 1, 2. It was 2, then -3, 0, 1, 2, 3, in which they share the same. So it's just 2 and -3. So the x-intercept here will let y be 0. So take -5 to the side, becomes +5, where x. So we are going to say 4 and 5. Okay, then you will then sketch. So this is the graph of G. This is how you're supposed to sketch the graph of G. So I hope you saw, guys, what is happening. So let's go to the last question in this case. Use the graph to determine the values of f of x where f of x is greater or equal to 0. Actually, this is where the graph of y is greater or equal to 0. So where y is greater or equal to 0, it's above, guys. It's above the x-axis. It happens here. This is where the y values are positive. This is where the y values are positive. Hence, we are going to focus on these x values, which is -1 and 3, to get 4.1.5. Right? Remember, use the graph to determine the values of x where f is greater or equal to 0. So we are going to focus on the x values, but we are going to look at where y is greater than 0. That's above the x-axis, where y is positive. So here the x value, it's lesser than, so it will be x is lesser than -1, or here and the x values are greater, so it's going to be x is greater than or equal to 3 in this case. Hope you saw, guys, what you were supposed to do in that part. Okay, I guess now we are going to the second part, which is 4.2.1. 4.2.1, it's an exponential equation. So at 4.2.1, we are required to write down the equation of the asymptote of f. So in this case, guys, the asymptote of f will be y is equals to 0. Why am I saying so? Because we are not given. Because remember that in grade 11 we were taught this form. So meaning that it's not given here. We don't have the equation of the equation of the asymptote of f. So in this case, you could just say y is equals to 0. So okay, now we need to go to the second part, which is just 2 marks. Write down the equation of the inverse in the form of y is equals to. Okay, guys, without wasting time, let's put that into practice. So remember that we are at 4.2.2. At 4.2.1, I did say that y is equals to 0. So now we need to find the inverse. So to find the inverse, let f of x be y in this case. So it's going to be 1/3. to the power of x. For inverse, you swap the variables. Where there is y, there will be x, and where there is x, there will be y. Then we apply logarithm since we're working with an exponential. So it's going to be log base, which is 1 over 3, log base number, which is x, our number, so it's equals to exponent, which is y. So but they did say that we need to leave it in this notation, so we are going to say log 1 over 3 x. It's advisable that you pause the video while I'm working and work it out, then check the solution. In that manner you will benefit. Then at 4.2.4, at 4.2.3, sketch the graph of the inverse in your answer book. Indicate the x-intercept, the intercept, and one other point on the graph. That was 3 marks. So in this case, guys, when we want the y-intercept of this, because this graph didn't have a x-intercept, we will put 0 here. Then we know that 1 over 3 to the power of 0, it will be 1. So the coordinate here, originally it was 0 and 1. So what is the inverse of 0 and 1? You swap the coordinates. So it's going to be 1 and 0. So definitely we are going to have 1 and 0. So definitely we are going to have pass. We're going to have something like this in this case. Okay, going to have something like that. So that's you already shown the other 1 point, and you already indicate the intercept and 1 other point on the graph. Okay, already shown that. Then let's go to 4.2.4. Write down the equation of the asymptote of the inverse. So here let's go to 4.2.4. At 4.2.4, we supposed to write the equation of the inverse. So remember that what we got from here, we got log 1 over 3. So meaning that where there is x, we're now gonna put x plus 2. There was a shift, as we can see from this part, so it's x plus 2. So that's what we are going to have. So you will leave it like this. Then that's 2 marks. Okay, then right, then let's go to if they wanted the equation, we can also continue, but we will have x is equals to -2 in this case, right? We'll have x equals to -2. So let's go to 4.2.5. Okay, hope you're learning, guys. Hope you're learning. So let's prove this part. So we're supposed to prove that this f of x, let's start with the left hand side. Actually, the left hand side, we know that we were given as 1 over 3. Okay, 1 over 3. Then it was x here, then it's squared. Then still we have 1 over 3, but now the x value is negative. Okay, let's work it out. Okay, x times 2, the powers will multiply each other. In this case, we are going to have 1 over 3 2x minus -2 times x. That's going to be 1 over 3 to the power of okay, to the power of -2x. So we can write this, we can change this into exponential form. So it will be -3 to the power of 1 and 2x. We can also change this, 3 to the power of -1 and 2x. Okay, so -1 times 2x, that will be -3 to the power of 2x. -1 times 2x, that's going to be 3 to the power of 2x. So that's the left hand side. Now let's work out the right hand side, guys, so that we are on a safe side. So the right hand side, f of x, remember, we are given as 1 over 3 to the power. Where there is x, replace it with 2x, and where there is x, you replace it by -2x. Okay, so let's work it out. Even here, this will be negative 3 to the power of negative 1, and 2x, as well as negative 3 to the power of negative 1, as well as negative 2x. Okay, it's fine. This negative 1 times 2x, that will be negative 3 to the power of 2x, as well as negative 1 times negative 2x, that will be positive 2x in this case. So we can see this is a similar thing, guys. We already proved that. We have already shown that. So in other words, the left hand side is equals to the right hand side. Hope you find this video useful, guys. See you on question 5, where we will focus on. Let's see what we are going to focus on. So we are going to focus on a hyperbola. So this is a hyperbola. Okay, soon on Sunday this will be out. So this will be out, guys. We should wait for it. On Sunday I will release it, which is question 5 and question 6, as well as Monday next week we'll look at question 7, as well as question 8. We are going bit by bit. We should not be hasty, because learning is a process. We should not rush. So hope to see you on those videos, and don't forget to subscribe. You only subscribe once, and remember, we love you.